This is a quick video of the foundational module, which is on pages 1 through 11 in the book Problem Solving Guide for Mechanics and Thermodynamics. There's a bunch of problems on pages 10 and 11 to confirm you understand what is going on here. These are prerequisites for the course. Humans have used a variety of standards to measure things: lengths, miles, furlongs, fathoms, light years, meters, durations of time, seconds, hours, weeks, millennia, fortnight, centuries. When the values are expressed in different units, it's difficult to compare them or add them. It's not obvious whether the speed of 30 meters per second is faster than the speed of 60 miles an hour. It would be easy to compare them if they were expressed in the same units. So the key to understanding how to convert units is that you don't change the value. You just change the units in which the value is expressed. So an obvious example is 12 inches is 1 foot. Same distance. They're not different distances. The units are different. The way to convert the units of a value without changing the value is to multiply by 1. If you multiply by 1, you don't change the value. So let's convert the speed, the units of the speed of 30 meters per second, to miles per hour. Then we can determine whether 30 meters per second is faster than 60 miles per hour. So we start by writing the value. It's a speed, v equals 30 meters per second, and we're just going to keep multiplying by 1 until we get the units miles per hour. There's a good start. In parentheses here, this fraction is equal to 1 because the numerator is equal to the denominator. We could write it either way. We could put 1 minute on the top, 60 seconds on the bottom. Here we want the seconds on the top because we want to get rid of the seconds. We want to cancel out the second units. We want to eventually get hours on the bottom because we want the speed of miles per hour. 60 seconds is the same as 1 minute. That fraction is equal to 1. The second units cancel, and now the units are meters per minute. So 30 meters per second is the same as 1800 meters per minute. We're not there yet. Let's keep going. So now there's 60 minutes in 1 hour. Now we cancel the minute units. The second units cancel, and we have meters per hour. So we're almost there. We want to get rid of the meters. We put those in the bottom. And it happens that there's 1,609 meters in 1 mile. And now we have the answer. So the second units cancel. The minute units cancel. And we have a meter here and a meter way over here. Those cancel. And we have miles per hour. And we punch the buttons on the calculator. 30 times 60 times 60 divided by 1609. The number is 67.1. The unit miles per hour. So 30 meters per second is faster than 60 miles an hour. One type of conversion with which students have had trouble with over the years involving units raised to a power. For example, volumes, cubic centimeters, cubic meters. In the thermodynamics section, we're going to be working with PV is equal to nRT, the ideal gas law. Volume is often expressed in cubic meters, cubic centimeters, liters. We have to get it into cubic meters because the gas constant R is SI units, joules per mole per Kelvin. Joule is a Newton meter, so we have to get the volume in units of meters cubed. So there's a problem. It has a container with 100 cc's of helium. How do we convert that to cubic meters? So we start with the value itself. That's the value, 100 cubic centimeters, 100 cc's. Now, it's a very common mistake to say that 100 cc's is 1 cubic meter because there's 100 centimeters in a meter. It's important for us to understand why this is wrong. When you do this, this is centimeters cubed divided by centimeters. That's centimeters squared. So the unit here is centimeters squared meters. Nothing wrong with that unit. It's a mixed unit, that's okay. What does that volume look like? 1 centimeter squared meter. It's a square tube that's a meter long. 1 centimeter high, 1 centimeter across, 1 meter long. That's 100 cc's. 100 cubic centimeters, right? Let's convert another one of the units. What does this look like? The units are meters squared centimeters. You get rid of 2 of the centimeters, but there's still one more on the top. The number is 0.01. We have 100 divided by 100 divided by 100. So it's 0.01 meters squared centimeters. That's 100 cc's. What does this look like? It's a tile. It's 1 meter by 1 meter by a height of 1 centimeter. 1 centimeter like this, 1 centimeter like that. 1 meter, 1 meter, 1 centimeter high. You know how many cc's this is? Figure it out for yourself. To get to cubic meters, we have to convert all 3 of the centimeter units to meters. So we got to do it again. Now there's 3 centimeter units in the bottom. That's centimeters cubed. They all cancel. We multiply the numbers, and the unit is meters cubed, and we get 0.0001 cubic meters. 1/10,000th of a cubic meter. 100 cc's is 1/10,000th of a cubic meter. Let's look at a picture so we can see why this is the case. Here's a cubic meter. 1 meter high, 1 meter back, 1 meter across. This is 100 cc's. It's 1 centimeter by 1 centimeter by 1 meter, which is 100 centimeters. How many of these square tubes do I need to fill up this cubic meter? Well, I need 100 going down here, and I need 100 across. 100 times 100 is 10,000. So this, I need 10,000 of these square sticks to fill up this space. This square stick is 100 cc's. 100 cc's is 1/10,000th of a cubic meter. And this is a very common problem. Here's a video, nature video, about Ethiopian wolves.
The pack's hunting ground is about 8 square kilometers of mountaintop.
So, David Attenborough, the narrator, says 8 square kilometers of mountaintop. And the caption says 5 square miles of mountaintop. The closed caption company converted the units, and they did a bad job. Attenborough says it's 8 square kilometers. The subtitle says 5 square miles. These are not the same. There's 5 square miles. There's 8 square kilometers. 5 square miles is about 60% bigger. Here's the incorrect conversion. This is a very common mistake. 8 square kilometers, and then they convert, and they get square miles. But this obviously is not right because the units aren't square miles. Units are kilometers miles, which is the unit of area. This is wrong. Let's do it correctly. As usual, we start with the value itself. Here the value is 8 square kilometers. We want to convert the units of this area to square miles. We just multiply by 1 twice. 1 mile is 1.61 kilometers. Those are lengths. If we do it twice, we get rid of both kilometer units. This is kilometer squared in the top, kilometer squared in the bottom. And we take the calculator, go 8 divided by 1.61 divided by 1.61, and we get about 3. So 8 square kilometers is about 3 square miles, not 5 square miles. Been able to convert the units of a value into different units without changing the value is a prerequisite for the course. It's a significant part of the exams. Another prerequisite is mastering the trigonometry. You're going to need to get the components of a vector and a vector from its components. You're going to be doing this when we do projectile motion, when we do forces, when we do momentum. Let's go over a few of these. A child pulling a sled with a rope. Child's pulling up with the force of 50 newtons. The sled is moving in the horizontal direction. It's not moving in the vertical direction. We would like to get the horizontal component of that force. The rope makes an angle of 40 degrees above the horizontal, and the force is 50 newtons. How much of that 50 newtons is horizontal? trigonometric functions were designed to do just this. So let's start by sketching the vector. It's a vector diagram, 50 newtons, 40 degrees above the horizontal. The force can be decomposed into a horizontal and a vertical component. There's T sub x, the tension in the x direction, T sub y, tension in the y direction. Both of these are some fraction of the hypotenuse. The vector itself, whether it's a force, a velocity, a momentum, an electric field, that's the hypotenuse. The components are always smaller than the hypotenuse, or equal, never bigger. The fractions we want are the trigonometric functions, sine and cosine. Sine and cosine are fractions. It's a table, a lookup table, of the ratio of the length of one side to the hypotenuse. Definition of the cosine is adjacent over hypotenuse, the ratio of those two lengths. So the angle here is 40 degrees. Cosine of 40 is about 0.766. What does this mean? This means that the adjacent side, the side adjacent to the 40-degree angle, is 76.6% of the hypotenuse. This side, T sub x, is 76.6% of 50 newtons. We can solve this for T sub x. T sub x is the adjacent side, the hypotenuse is 50, and we get 38.3 newtons, which looks about right. The sine function you'd be used to get the vertical component because the sine is the opposite over the hypotenuse. If you have a 40-degree angle, the sine opposite is 64.3% of the hypotenuse, 32.1 newtons in this case. That's how to get the components of a vector. Now let's get a vector from its components. You're going to be doing a lot of this in Module 2 when we do projectile motion. You're going to have the horizontal and vertical component of the velocity, and you have to get the speed. The vertical component is 20 meters per second upward. The horizontal component is 30 meters per second to the right. Let's draw a diagram. This is 20 straight up and 30 across. How fast is the arrow going? It's going in this direction. And what direction is it going? What angle is it traveling? To get the speed, we can use the Pythagorean Theorem. We have the two sides, we need the hypotenuse. C squared equals a squared plus b squared. Hypotenuse is the speed v sub x plus v sub y squared. Let's put the numbers in, and we get 36.1 meters per second. That's how fast the arrow is going. That's the length of that vector. We can get the direction from the tangent function. Tangent is, I think it's opposite over adjacent. Yeah, opposite over adjacent. It's 20 meters per second divided by 30 meters per second, which is 2/3. So we need the angle whose tangent is 2/3, and that's the arctangent function, or inverse tangent, whatever you want to call it. Theta is arctangent of 2/3, and we can use a calculator to get 33.7. So the arrow is moving 36.1 meters per second at 33.7 degrees above the positive horizontal axis. So these manipulations, converting the units in which a value is expressed, whether it's a volume, speed, distance, acceleration, and getting the components of a vector, and getting the magnitude and direction of a vector from its components, are prerequisites for the course. As a foundations module exam on Blackboard, you should take that exam before the class starts. If the exam's not easy, you're going to have trouble. You're going to have to develop this mastery before the class starts. So the way to develop that mastery is to do a lot of problems. There's a bunch of problems on pages 10, 11 in the textbook until you have achieved mastery. Get to work.